Hey guys, welcome to lecture 2.2. Today we are talking about simplifying algebraic expressions, and then when you read a word problem, converting it into an algebraic expression and finding the answer to the word problem by solving that algebraic expression. So here we go. What do we mean when we say expression? An expression is something like 2x plus 5, okay? It's not yet a problem or a problem that we can solve because it doesn't equal anything. So when we are talking about problem solving, we need to first understand the problem, then work on translating the problem into an equation. So if we have 2x plus 5, that's actually called an expression because there is no equal sign. If you have an equation, that means you have an equal sign. So now maybe we have 15 on one side of the equal sign and that same 2x plus 5 on the other side of the equal sign. Now you can figure out what x is, okay? Here we can put in an x and find the answer, right? And that's how we graph things is if we said x is 1, y is 7, so that is the point 1, 7 on a graph. When you just go into desmos.com and, one second, I'll show you. All right, I think I should show you. So you're right now looking at the paper. I'm going to show you Desmos. Again, this is an app that you can use, or a website that you can use during each of our exams. So feel free to open Desmos and see if you're stuck on a problem, if it can help you in any way. So our equation was 2x plus 5. Watch, as soon as I type in an x here, I can see a graph. 2x, I can see a different graph. 2x plus 5, a different graph. Okay, so these linear equations or these variables are also graphable. They are also lines on a graph, okay? So up here we have 1 comma 7, right? I said that when I made x 1, the answer to 2x plus 5 was equal to 7. And then we turned that into the point 1 comma 7, just like x comma y is a point on the graph, and we'll talk about that later. But look, that is on the it's on the line that is 2x plus 5. If x was 0, right? 2 times 0 plus 5, what would the answer to 2 times 0 plus 5 be? It would just be 5, right? That's also on our graph. So that's what we're doing when we're talking about algebra and graphing and linear equations and all the rest of it, basically. These are all interconnected. So expressions means there's no equal sign. You can put whatever you want in for x and you'll get a y. You don't need an equal sign. But when we say 2x plus 5 is equal to 15, that's no longer going to be a line that goes on forever because we only have one y, and now we need to find the x for that y, right? 2x plus 5 equals y. There are infinite numbers of x it could be. 2x plus 5 equals 15, or when y is 15, x is just going to be one number. Let's go back to Desmos. When y is 15, y is this, the up and down. When y is 15, x is going to be the number 5. See that? So, or we can solve for it, okay? Subtract 5, 2x equals 15 minus 5 is just 10. Divide by 2. 10 divided by 2 is 5. So 5 is x. When 15 is y, right? Or we found the value of x because of the information that we had. Good? All right, so to solve problems, understand the problem, translate it into an equation. An equation has an equal sign. Solve the equation. So we solved this one for x. And then interpret the results. Does that answer make sense to the question they asked you. Then state your conclusion. It might be days, it might be inches, right? So let's look at this sentence. Twice a number plus 3 is the same as the number minus 6. So now again, we're thinking about what each of these terms means, okay? A number. If you don't know what the number is, we're going to use a variable. I like the variable x. A number plus 3 is the same as the number. So now it's the because, so this is more of an English lesson. The because we already referenced it over here as a, and we're referencing the same a number. So we know that's not a new number. It's the number we were talking about earlier in the sentence. So twice a number plus 3 is the same as the number minus 6. What else do you know or notice is the same as, I think of as an equal sign, yeah? We know plus, right? And we know 3. Twice a number plus 3 is the same as the number minus 6. Well, I know what minus 6 is too. It's kind of like plus 3. Minus 6. Right? The only part we're missing now is this twice. Twice. Think about this. If I do something twice, what am I doing? I'm doing it two. What's another way to say twice? 2 times. If you do something 2 times, you've multiplied it by 2, right? Times 2. Twice. So we have 2 times a number plus 3 is the same as the number minus 6. I would write that as 2 times a number. You can draw a dot if you want. I'll make my X a little bit fancy because I made a multiplication sign, which is not good in algebra. Plus 3 is the same as that number minus 6. Good? 2 times x, the best way to write that is just right next to each other. 2 times x plus 3 equals x minus 6. Good? This can mean multiply. I guess this can be multiply, but I should not have done it that way. That's the hard way to do it. This can mean multiply. This can mean multiply. This can mean multiply. And this can mean multiply. Those are all just, you're multiplying 2 numbers together. Good? Okay, now, what did it say? What were our instructions? Understand the problem. So I translated it. I understand the problem. I knew what twice meant. I knew what minus 6 meant. I knew when I had the phrase the number to change it to x. I understand it. I translated it into a problem or an equation. Now I need to solve the equation, part 3, okay? So, to solve an equation, you want to be very respectful of the equal sign, and then you want to move all the variables to one side, generally to the left, and all of the constants to the opposite side of the equal sign, okay? So my variable is 2x. I have another variable on this side of the equal sign. It is x. I want to combine these. You can't combine things across the equal sign, right? So I need to move it. There's a difference between just adding them together and moving them. They are separated by an equal sign, so we're going to move it. It's good to have your variables on this side, but it's also good to have your variables be positive. So if these were switched, I would consider moving the x over here just to keep it positive. I would rather have a positive variable than a variable on the left. 2x minus x is just x plus 3. X minus x is gone, so x plus 3 is negative 6 now. Good? So just like we put the variables on this side, we're going to put the constants on the other side. So we're adding 3 to x. We want to isolate x so it's alone. The inverse of adding 3 is subtracting 3. So I'm going to subtract 3 here. anything I do to this side of the equal sign, I have to do to this side of the equal sign. So these become canceled out, or they become zeros. X plus 0 equals -6 minus 3 is a -9, because we are combining two negative numbers, so they're going to become a greater absolute value, but they're going to remain negative, right? So check your answer next. Okay, so put that -9 excuse me. Put that -9 back into the 2x plus 3 equals x minus 6. 2x plus 3 equals x minus 6, but x is now -9. Use parentheses so you don't make mistakes. Times 2 plus 3 should equal that number minus 6. So 2 times -9 is a -18, plus 3 becomes -15. And then on the other side, -9 minus 16 is also -15. So we can confirm by substituting it back into the equation that we made that x is -9 does make this true. The number is -9. Example 2, the product of, so read it all first. The product of twice a number and 3 is the same as the difference of 5 times the number and 3/4. Find the number. So I keep seeing the number, right? The product of twice a number, maybe make it y this time, and 3 is the same as the difference of 5 times the number and 3/4. Find the number. So find y, right? Just like we found x up here. Think about what the product of means. The product of means multiply and sometimes means plus, but we're taking the product of two different terms, twice a number and 3, okay? So we're taking the product of twice a number and 3 is the same as right? Is the same as, just like is the same as the difference of the difference of 5 times the number and 3/4. So again, product means multiply, so we're going to multiply this times this between them, product and difference and, okay? So that we're taking the difference of 5 times the number. So 5 times the number means 5y. Just like twice a number means 2y. The difference of 5 times the number and 3/4. So just the other half of the difference equation is 3/4. Okay, let me write that down here. Twice a number is 2y. The product of twice a number and 3 just means we're going to multiply it by 3. The product of twice a number and 3 is the same as the difference of 5 times the number and 3/4. Okay? We translated this first sentence into a math equation by highlighting the math operations and then representing them as numbers and letters, right? Now we need to solve the equation. So again, I want variables on one side, constants on the other. But here my 5y is bigger than my 2y, so I'm actually going to move my variables this way so that they stay positive. Good? All right, so I'm going to move my 2y by subtracting 2y. So now I have, oh, I'm not subtracting 2y. Sorry, I'm multiplying. Goodness, kind of want to start this over. That's so embarrassing. 2y times 3 is just 3 times 2y, right? 5y minus 3/4. So 3 times 2 is actually 6y. So now we have 6y equals 5y minus 3/4. Very different problem. I'm going to move my variables over here. See, there's nothing. Don't be scared to do things a different way than I'm doing them. A of all because I'm making mistakes, but B of all because it doesn't matter if you move the variables that way or that way. Subtract 5y from both sides because I'm moving my variables to the other direction now. 6y minus 5y will just leave me with y. 5y minus 5y, those cancel, and I just have negative 3/4. Good? Okay. Now, how do I check that negative 3/4 is the right answer? So my final equation was 6y equals 5y minus 3/4. And I say y is negative 3/4. What you want to do is replace that. 6 times negative 3/4 is equal to 5 times negative 3/4 minus 3/4. Okay? Easiest way to check it is in your calculator. 6 times negative 3/4 is going to give me negative 4.5. 5 times negative 3/4, but then minus 3/4. Oh, let's see. All right, let me show you that one again. Let me fix that one. Oh, I can't now. I went past it. Forgot that sign. Minus 3/4 should give you the same exact number in your calculator. If you will be using your calculator with fractions, I would like you to try this just to make sure that you also get the same number, so then you can be sure that you're putting calculators into your calculator. Or sorry, you're putting fractions into your calculator correctly. For example 3, it says a car rental agency advertised renting a Buick Century for $24.95 per day and 29 cents a mile. If you rent this car for 2 days, how many whole miles can you drive if you only have $100 on a $100 budget? So what you want to do is you want to think of what variables you need. In the previous 2 examples, we only had the variable x, right? But we have a car, we have the days, right? What numbers do we have? We have a number of days. We have miles. And we have the cost to rent the car, right? So we don't just have one variable, we have 3 variables. You have $100, right? I'm renting my car for 2 days. They are asking me how many miles. So we do only have one variable. I wouldn't call it x, I would call it m because it represents the miles, but we have to create an equation using the cost of the car, the days of the car, and the variable for miles, okay? So you can rent the car for $24.95 a day. So the day times $24.95, right? Because if I have it for 1 day, it'll cost $24.95. If I have it for 2 days, it'll cost $49.90, right? If I have it for 3 days, we're just multiplying the number of days I have it by the number $24.95. That's where I got that, okay? So part of the equation is the number of days you have it multiplied by the cost per day. And, right? And 29 cents a mile. So for every mile I drive, I have to multiply those miles by 0.29 or 0.29. Those are the same number. okay? Just like the number 17 is the same number as 17.0. Those are the same number, so you can put a 0 in front of a decimal, the decimal point, or you can leave it without a 0 in front of the decimal point. It doesn't change the value of the number. So I'm renting my Buick for $24.95 a day and 29 cents a mile. How much it will cost oh, sorry. And I know it'll cost $100, but I shouldn't have written it like that. I liked days times $24.95 plus miles times 29 cents equals the cost of your whole rental, right? Now we're going to go back and we're going to put the 100 in for the cost, the amount of money we can spend, the 2 in for the number of days we have the car for. So it's going to be 2 times $24.95 plus M times 0.29 equals $100. 2 times $24.95 plus, and I'm going to switch these because I like to have the number in front of the variable. 2 times $24.95 equals 0.29M plus 0.29M equals 100. So the first thing I'm going to do now, all we're doing now is we're solving for our one variable. What's our one variable? It's M. 24.95 times 2 gives us 49.9. If you know it's money, you can say it's 49.90, or you can just leave it as 49.9 plus 0.29 M equals 100. Okay, we're working on simplifying. We're simplifying to solve for M. So I want to isolate M. M is already on the left, so I'm going to move my constant to the right. Right now, M is having 49.9 added to it, so I'm going to subtract 49.9 from it. And then I'm going to subtract 49.9 from the other side as well. These cancel. I get 0.29 M is 100 minus 49.9 is 50.1. There is one more step, and that is M is being multiplied by 0.29. So I'm going to divide it by 0.29 because that is the opposite of multiplying. 0.29. So I'm going to take that 50.1 and I'm going to divide it by 0.29. Do you think it's going to be a bigger number or a smaller number than 50 if I divide it by a fraction? Try to decide before you press the button. It's more. So 50.1 when divided by 0.29 becomes 172.75. 172.75 is equal to M. So that's the amount of miles you can drive. How many whole miles can I drive for $100? 172 miles. And then you can also put that back in, right? You can say 172 times 0.29 plus 24.95 should get me pretty close to 100. I should not go over 100. 172 times 0.29 plus 24.95 times 2. 99.78. So I will not have gone over $100. Example 4 says the measure of the second angle of a triangle is twice the measure of the smallest angle. The measure of the third angle of the triangle is 3 times the measure of the smallest angle. Find the measures of the angles. I need a straight edge. All right, let's make a picture of the triangle. don't love that one. Because they're not, these two look too close to me. Ooh, yes, okay. Is that one better? That one's a little bit better. All right, the measure of the second angle. So I'm just going to call this the second angle of a triangle is twice the measure of the smallest angle. The measure of the third angle, so the third angle is going to be C, the second angle is going to be B, and the smallest angle is going to be A. The measure of the third angle of the triangle is 3 times the measure of the smallest angle. So the smallest angle is A, right? Because it's the smallest. The second is B, because B is the second letter. We already talked about one, and that's A. The measure of the second angle of a triangle is twice the measure of the smallest angle. We talked about what twice means. Twice means you're multiplying it by 2. So the measure of B is 2A. The measure of the second angle of a triangle is twice the measure of the smallest angle. The measure of angle A is just A. The measure of angle B is 2A because it's twice the measure of the smallest angle. The measure of the third angle is 3 times the measure of the smallest angle, so that's going to be 3A. Do you agree? Okay, find the measure of the angles. For this question, you also need to know that a triangle has 180 degrees if you add together angle A, plus angle B plus angle C. Those 3 together always make 180 for a triangle, which also makes a straight line, but this isn't geometry class. So we're going to say 180 is angle A plus angle B plus angle C, right? But I can't solve something if I have 3 different letters, right? Just like I couldn't solve C equals 2495D plus 0.29M. I can't solve that, right? Because there are 1, 2, 3 variables. If I have 1 variable, I know how to solve 1 variable. I don't know how to solve for 3 variables. So what we did was we changed so that A plus B plus C, we can represent all of those with just the letter A. So we say B is now in terms of A. So the angle A in terms of A is just A. The angle B in terms of A is 2A. And the angle C in terms of A is just 3A. So we put all of those terms all of those variables in terms of the variable A. They all add up to equal 180. So now I just combine like terms. A plus 2A plus 3A. So 1 plus 2 is 3, plus 3 is 6. All right? Now, one step. Divide by 6. So that was A plus 2A plus 3A gives me the 6A. If I divide it by 6, I'll just have the 1 again, okay? But I have to do the same thing on this side. 180 divided by 6 is 30. So 30 degrees is A. That means that the smallest angle it should be capital A. Angle A is 30 degrees. Just like temperature, we write the degree sign. Angle B is 2A's, right? Which is 2 times 30 degrees, which is 60 degrees. And angle C is 3 times A, which is 3 times 30 degrees, which is 90 degrees. If you add 90 plus 60 plus 30, you'll get 180. And you'll see that 60 is 2 times 30 and 90 is 3 times 30. So the smallest angle is 30. The next largest angle is 60, and the largest angle is 90. Okay. The sum of 3 consecutive even integers is 252. Find the integers. Consecutive means there is one after the other, right? 1, 2, 3, 51, 52, 53, 105, 106, 107. Good, those are consecutive integers. But consecutive even integers means 2, 4, 6, right? We're skipping 3, we're skipping 3, we're skipping 5. We're only talking about the even ones. 2 and then 4 and then 6. Or 88, skip 89, 90, skip 91, 92. Okay? So if the sum of them means we add. If you add 3 consecutive even integers, you'll get the number 252. The sum of 3 consecutive even integers, 18, 19, and 20. This would be the sum of 3 I can't even do that. The sum of 3 consecutive even integers, 18 and 20 and 22. Right? This is the sum of 3 consecutive even integers, 18 plus 20 plus 22. You get 60, right? 60 divided by 3 also, because those were 3, is your middle number. So that's funny. The sum of 3 consecutive even integers is 252. Find the integers. The sum of 3 consecutive even integers here is 60, okay? But you don't worry, we don't need to just guess. What we want to do is just come up with one of them, right? One of those numbers is going to be the number x, the number, right? The number we're talking about that we don't know yet. What is the next consecutive even integer? For example, if x was 18, what would 22 be? 22 would be x plus 2, right? And then what would 22 be? X plus 4. Tricked you. Nope, I was just going to write 2 again. And that would have been a mistake. So 18 becomes x. The next even integer after x is going to be x with 2 added to it, right? Then we're going to add the next even integer, which is that same x added 2, right? So another way to write it would be 18 is x, 20 is x plus 2, and then 22 is that same x plus 2, but with 2 more added, right? We have our original number, we went up by 2, and then we went up by 2 a second time. So we have x plus 2 for the next even integer, and x plus 2 or x plus 4 for the next even integer is something, right? Is y, is 252. Good? Okay, so what do we need to do with this information? I would take away the parentheses. 252 is x plus 2 plus x plus 4. The parentheses just represented that this was one number, and this was another number, but we don't need them for the math portion, right? Now I'm just going to combine like terms. X and x and x become 3x. Positive 2 and positive 4 just become 6. 252 stays the same over here. Now I'm just solving for x. Subtract 6, subtract 6. 252 minus 6, 246 is 3x. Divide by 3, and I get 82. Good? So the integers are 82. The integers are 82. That's only one number. What if it was 82? How many 3 consecutive even integers? So 82 3 times? Nope, that doesn't give me 252. We have to now put those back, just like with the angles of the triangle. We need to put the x back, right? So this one's now 82. This one's 82 plus 2. This one's 82 plus 4. Okay, so our numbers are actually 82, 84, 86. Those are consecutive, 2, 4, 6, and they'll give me 252. I think my math lab will just ask you to draw it like this: 82, 84, 86, not as a math problem, because it's what are the numbers. All right, last 2 examples. Find 25% of 1,500. So make sure you know how to do percents. 25% of 1,500. Think about what a percent is. What a percent is if this is 100, right? Of something, if this is all of it, 25% is 1/4, right? We don't need to convert it to a fraction, but we should convert it to a decimal. So a good way to convert a percent to a decimal is take the whole number of it. So 25% is 25, divide that by 100. 25 divided by 100 is 0.25, or maybe you just remembered how to convert between percent and decimal. 0.25, and then of means multiply. 0.25 times 1,500. Because let's look at this, because 25% is 0.25. 100% is 1, right? And 1 times 1,500 is just going to give me that same 1,500. So that's your proof. Whereas 0.25 of 1,500 is 375. 0.25 times 4 will give me my 1 whole, right? So 375 times 4 should give me back my original number. But that's how you do a percent. Finally, last question, find the perimeter of the rectangle. So perimeter is equal to the length of a rectangle the width plus the length plus the width. It's like you're building a fence. You're starting here and you're saying 5, you're turning, you're adding 8, you're turning, you're adding this amount again, which is just another 5, and then turning again and you're adding another 8. So you have 5 plus 8 plus 5 plus 8. We write it as length plus width plus length plus width, or you can write it as 2 lengths and 2 widths, right? Because we could say, oh, sorry, you couldn't see that. Because we could say that this is, what's the length? The length is 8, plus the width is 5, plus the length again is 8, plus the width is 5. Or we could say that that's 2 lengths, 2 eighths, and 2 widths. So that's that equation. That's that equation. Either way, you get 26 centimeters. Good? All right, that is all I've got. I think with that information, you should be able to do all of the homework. Email me if you have any questions, and thank you so much.